Hey guys, today we're going to be doing the 2017 Open Contest Silver Problem paired up. Now in this problem we have M cows with different milk outputs and our job is to pair them up for them to be milked. Now the milking is going to take place simultaneously, and if cows of milk outputs A and B are paired up, then it takes a total time of A plus B to milk them both. Essentially, all we're doing is we're splitting the M cows into pairs, and we want to minimize the maximum of all of those sums of pairs. To get a better understanding of the problem, let's jump into the sample input. So the sample input is given in the format of number of cows and milking time. So there's one cow of milking time of 8, and there are 2 cows of milking time of 5, and 1 cow of milking time of 2. So if we write all these cows down, we have 8, 5, another 5, and then 2. Notice the order of the cows doesn't matter because we're going to pair them up anyways, so we can just sort them for now. So if we sort this, we have 2, 5, 5, and 8. Now the optimal solution is pairing the 2 with the 8 and the 5 with the 5. And so this will get us 2 plus 8 and 5 plus 5. And all we need to do is take the maximum of that to get the total time. So this would be equivalent to the max of 10 and 10, which is just going to be equal to 10. So how do we actually go about solving this problem? Well, if we wanted to try every possible pair combination, that would take too long, and that would be very annoying to code. The clue that led me to the solution of the problem is this fact that we're pairing the outer cows first and then pairing the inner cows. And this pattern is familiar to me when I'm adding an arithmetic sequence. We can see that if we add 1 and 6, we get 7, 2 and 5, we get 7 again, and 3 and 4, we get 7. Now we can see that 7 is the minimum of the maximum of our sum of pairs in this arithmetic sequence here. But what we're given in the input is not an arithmetic sequence. It is not going up by the same number. It's just a random array of integers that we have to work with here. But it's still good to give this solution a try and see if the same thing works on the arithmetic sequence and on a random array of integers. And you'll see that this solution is actually the intended solution for this problem. Okay, so the solution is good and all, but how does this work? Well, we're given here 6 integers, and I've named it A, B, C, D, E, F, and they're sorted already in ascending order. Our best solution is going to be doing maximum of A plus F, B plus E, C plus D. So first let's try to assume that B plus E is the biggest. We could very well assume that A plus F is the biggest or C plus D is the biggest, but just to make an example, let's put B plus E as the biggest. So let's say the biggest is B plus E. Now, let's just try to make another order that can make the maximum of the pairs smaller than B plus E. So for B, let's pair it with D because D is smaller than E, and so B plus D is going to be smaller than B plus E. Okay, well, which one are we going to pair E to? Well, we can't pair E with C because C is bigger than B, and if we paired E with C, then E plus C is going to be bigger than E plus B. So let's just pair it with A. Now everything is pretty good right now because B plus D is obviously smaller than B plus E, and E plus A is also smaller than E plus B. Okay, we're only left with C and F, and we're forced to pair these two together. Now, if we pair these two together, we can see that C is bigger than B, and F is bigger than E, and so C plus F must be bigger than B plus E. So this solution is actually worse than this solution over here. And it turns out that there are no better solutions of pairings unless we pair B and E together, just like we have in this solution. And you can try to prove it to yourself by assuming that A plus F is the biggest or C plus D as the biggest, but you're not going to get a better solution than just pairing the outer layers like this. Now there's one more catch to the problem here. We're given the input in the format of number of cows and milking time. And we can't write out each cow independently and store it into an array because there are going to be 10 to the 9 cows, and that would be too big to fit into an array. But we still need to do the same logic where we pair the leftmost cows with the rightmost and keep going until we reach the center. And we can do a similar approach for this data structure here. We can keep an index at the start of the array, and we can call it left. We can keep one at the end of the array, we can call it right. Now we're just going to try to pair left with right. Well, we can see that we only have 1 cow for the left, and we have 4 cows for the right. All we're going to do is we're going to pair that 1 cow to the right. So we are going to subtract 1 cow here, and we're going to subtract 1 cow here. Now we can see that we don't have anything in the left, so we can increment the left. Now it's going to point right here. Now we're going to compare the left and right again, and we can see they both have 3 cows, which we're going to erase it, and we're going to change it to 0. Now both of them don't have any cows, so let's increment the left and right. So they're all going to be pointing at this cow over here. Now because this cow has 2, we can just pair the 2 with each other. So we can just pair the 4 with itself, which is going to be 4 plus 4. And if we use the strategy of keeping track of 2 pointers, and every time they move, we're going to take the maximum, we're going to arrive at our final result. The code of this problem can seem pretty intimidating, but if we break it down, we can make it very simple. So all we're going to do is we first read in n, and we're going to store the cows in the format of pair int int. The first int is going to be the number of cows. The second one is going to be the milking time. Okay. Then we're going to sort the cows by the second int. So that would be the milking time. We're going to sort it by the milking time. Now we're going to keep track of our 2 pointers, left and right, just as I've talked about earlier. We're going to set our result, final result, to 0 first. And we're going to go into a while loop saying if the left is smaller than right, then keep going. Because we cannot have the left going over the right at any point in time. So we're going to do our result right now. So we're just going to say the result equals the max result and cows left dot second, which is just the milking time for the left, plus cows right dot second, which is just the milking time for right. So we're going to add them and we're going to max it into the result. Then we're going to try to increment the pointers to set up for the next loop. So we're going to say if cows left dot first is smaller than cows right dot first, that means cows left has less cows than cows right. We're going to take all of cows left's cows and pair it with cows right. So we're going to say cows right dot first minus cows left dot first, because we're pairing every one of cows left's cows. Then we're going to say cows left dot first, we're going to set it to 0, because it has paired all of its cows, and we're going to increment the pointer of left. Okay, now we're going to do the opposite situation where the right has less cows. So if cows right dot first is smaller than cows left dot first, then the cows right has left less cows. So we're going to pair all of cows right's cows into cows left. So we're just going to say cows left dot first minus cows right dot first, and we're going to set the cows right dot first to 0. We're going to decrement right. And now we have another situation where we have the same number of cows, and we're just going to set both of them to 0, and we're going to increment left and decrement right. Okay, now we have done the whole thing, but there's one more thing to check, which is when they're on the same element. And when they're on the same element, we can just say if that element still has cows left over, it has to be even because the input is guaranteed to be even. So we're just going to say result equals max result of cows left dot second, which is the milking time for that cow that the 2 pointers are pointed on, times 2. And that should be the end of our program. This problem can really trick a lot of people up by the gigantic amount of cows in this case that we need to pair. But after we know the pattern of pairing the outer cows and working inwards, we can use the given data structure to pair the cows very easily with 2 pointers. Hope you guys enjoyed this USACO problem, and I'll see you in the next one.